Sebastian?
Yeah, fine.
So I'm ready to. I can start. Yes.
Yes, please go ahead.
Hey everyone, I am the CEO and co-founder of timbr.ai, an Israeli startup, and I'm going to show you how we can leverage our knowledge graph to run graph algorithms on data warehouse and data lakes. So to give you a little bit of a background, we partnered with DBpedia last year to support querying DBpedia knowledge graph in SQL. So anyone who's familiar with SQL can use the DBpedia knowledge graph and query it, but also integrate it with its own data sources. So I'll share the screen and I'll show you a quick demo of the platform and how it works. I'll wait for the. Okay, so this is the timbr platform in which you can create an ontologies on top of your existing databases and connect your data to those ontologies. You could also import existing ontologies and map them to your data. In this ontology, we're looking at calls between people, and here I can easily click on a person and I can see the properties that were defined in the ontology. So we have the first name, the last name of the person, we have the city, the age, and the phone number. Now, we also have calls that represents a call between two persons. In the call concept in the ontology, we have the call ID, the callee number, the caller number, the device ID, the duration, and the started at of the call. We can also see the relationships, which are the callee, caller, which are relationships to the person, and also a relationship to the device, and the device that was made to do that call. We can also visualize our relationships directly in the knowledge graph by showing the relationships. So here I can see the callee, the caller, which is a person, and I can see the relationship to a device. We can also fetch a sample of data while exploring the ontology by clicking on fetch sample data. So here we can see the list of people. So we have the city, the phone number, the first name, the last name, and we can explore the people in the knowledge graph. And it's also true for any concept in this ontology. Now, what Timbr does is exposes all of the ontology in a virtual schema. So for an SQL user, he could work with this knowledge graph like it's just another schema in the database, and each concept represents a virtual table. So let me show you how we can query this knowledge graph. If we want, for example, to get all the calls between people, we can easily query the DBtimbr, which is a virtual schema, and the call concept. We can see in the metadata all the available properties and relationships available. So we can get the call ID, we can get the callee, which is a person, and all of the properties of that callee. We can see the caller, the person and all of his properties, also the device, and additional properties of the call. Now, when I execute the call with Timbr, what we do is we take this query, rewrite it to the underlying database, and we give you the results. So here we can see the results of calls between people. For each query we do in Timbr, you can easily do an explain query, and you can see what was generated to the underlying database. In this example, we're saying there's two joins to connect the call table with the callee and the caller. Now, if we would like to run a graph algorithm just to see, for example, community of people who talk with each other, this is something that's not possible to do with SQL. But we've added this capability that anyone who's familiar with SQL can now start running and executing graph algorithms directly in the query language itself. So let me show you an example of the Louvain algorithm. What Timbr does to support graph algorithms is to expose a new schema called gtimbr, and for each algorithm, you can see what you can get in response. So for the Louvain algorithm, which gives you communities, you can get the ID of each node in the graph and the community he's related to. The way we've implemented it is that you can query this virtual concept that represents the Louvain algorithm, and you call it as a table function. A table function is when you call a table like you would call a function. And what you would pass in SQL to a table function could be a select query. So here we're querying the ID and community of calls between two people, and we're counting how much calls they had with each other. This number represents the weight of the edges in the graph of the algorithm itself. So I can run this algorithm and I can easily see all the IDs, which are the phone numbers, and in which community each ID is related to. Now, by running this algorithm and matching people to their communities, now we can enrich our knowledge graph, and we can map the table that was created by the algorithm directly in the ontology. So now we have an inferred community of people by calls, and we can create that relationship to the people. And let me show you how we can further explore those results. So once we execute the algorithm and map this to the ontology, we can now get, for each person in the knowledge graph, we can get all of their communities. So we get the age, city, the company name, the community, and we can even explore this further. In timbr, for each query, you could click on the explore button, which now gives you a way to visualize your queries. In this example, I will show you how I can understand better the communities that was generated by the algorithm. So I'll click on the bar chart visualization. The metric that we want to do is count by a community. Let's start count by community. And now I get in each community that was created by the algorithm, how much people are in each community. We can even do a breakdown, for example, by city. So now I'll run the query. I get the breakdown per city, and I can also stack them, so it will be easier to visualize and understand. So here, for example, we have for each city how many people are related to in each community. This helps me better to aggregate and visualize the results from the algorithm. Another approach to explore this is using the Data Explorer in Timbr. So I can go to the Data Explorer, click on the ontology, which is the Timbr calls, choose, for example, an adult concept, which represent people who are adults, and I can limit the results. So in this example, I'll just limit this to 100. And now I get a graph of 100 people, adults. So I'll move it to full screen so you'll be able to better view it. Now for each node in the graph, we can see the properties, the relationships, and I can continue exploring the knowledge graph. Let's see if we can find all the communities of those adults. So I can go to find data connection, choose the connection I'm interested in. I can increase this so it will be bigger. And I can see now we're going to the community concept, and we can click on the properties. Here we will also limit to 100, and we'll click on find data connection. Now we can see, for example, each adult in which community he is. We can take this one step further and see all the calls of those adults. So for each adult, we can go to made call. We can bring, for example, all the properties of a call. We can increase the limit, and we can find data connections again. Now we can see all the calls made by those adults. Now we can get the callee of each call and complete the relationships in this small graph. So we get the callee of each person. Here we also select all the properties, increase the limit, and we'll run find data connections. Now we can see adults in each community who talked with other adults, but how can I understand which one of them is more important in the graph? So even here in the data exploration, you can run graph algorithms. You can do it by PageRank. You can do it by a centrality, for example, by incoming and outgoing relationship. And now I can easily see which communities are more important, but also which adults, for example, Noah. And I can click on him and see, for example, all of his properties and his relationships. And this just gives you an overview how you can both visualize the algorithms in dashboards, but also in the graph itself. The last algorithm I want to show you is the PageRank algorithm, which is very famous. And in this example of the PageRank, we're running the algorithm directly on a table in BigQuery. So for running graph algorithms in Timbr, you can do it directly on your data or directly on the knowledge graph that was created by Timbr. So let me show you the table that we're running the algorithm on top of. So here you can see, for example, we're looking at the knowledge graph of entities that was published by GDelt last year, which gives you all the entities for each news article. So they use Google Natural Language API to extract entities for each news article in the world. In this example, we can see the URL, the entities that were extracted, the type, and they also connected to the Wikipedia page. So this could also be integrated to the DBpedia knowledge graph by using the Wikipedia page. And we can see all of those types. Now in Timbr, what we've done, we've created a query to get the entities of all the articles in the last day, but we filter it by consumer goods entities. What this gives us is the rank of consumer good entities published in the news. Now, in this example, we will filter the English results because GDelt is multi-language. So even if the article is in a different language, this will also filter and work on this. And now we can easily query and see what we get back from a PageRank algorithm, which is the rank of each node in the graph and the ID. So let's run this algorithm. Now what this does is issues a query to BigQuery and run the algorithm, and then shows you the results for each entity, the relevant rank. So we'll wait for the results. So this is basically waiting for a BigQuery. Maybe we'll try again. Let's see. So until we get the results, what I would like to show you is that for each query that we do here, whether it's based on the knowledge graph or the actual tables in BigQuery, you could also add the parameters of the algorithm itself. So for example, if I want to change the alpha, which is one of the thresholds parameters of PageRank, I can easily insert here the alpha parameter, which is consisted in a PageRank algorithm. Now in Timbr, we got the results back. So for each entity in the graph, we can see the rank. For example, I can filter by, let's say, iPhone, and we can see the rank of all the different mentions of iPhone in the news.
Sorry, you're
and
running
we can see iPhone. Oh, sorry. So
no,
just to finalize, just one thing to finalize, you can choose where to run the algorithms. So you can do it in Python Network X. You can use Apache Spark to run the algorithm in a distributed manner, or you can use NVIDIA CU Graph framework to run this on GPU. So you get a lot faster results that you've seen here. Thank you very much. And if you have any questions, I'll be happy to answer.
So took away your presenter
okay.
role.
Thank you very much.
Yeah, so I have a question, right? So So we have seen this also with Margaret uses like a lot of different sources, more in a linked data style fashion, and you are kind of like loading it. You need a materialized graph in a sense, yeah. So you know, linked data is kind of like an ad hoc way to gather information from somewhere and then analyzing it. But you would need to have a dump, and then you connect to different processing engines. Is that the correct understanding of this? Amit?
So in terms of how it works, we don't do any materializations, but we store the output of the algorithm directly on the database itself. So it's available for queries and integration with the existing data. So we just materialize the output of the algorithm, not the knowledge graph itself.
But there needs to be some data in there somehow, or I mean, you have a basic, you need to load the data first, right? Or you aggregate it from somewhere.
Yes, so to run the algorithm, we do need to build a subgraph based on the query. So in the table function, when you write the SQL query, you just write the nodes and relationships you want for the algorithm. And then we generate the graph, run the algorithm, and store the results back in the database. So you don't need to do it manually like it's done today.
Okay, I see. Any more questions? I think there's none in the chat.